All right, so welcome everyone to Threat Hunting, a Practical webinar. Before we get started, a couple of housekeeping notes. This webinar will be recorded and we will be sending out the presentation to all who registered. We will be answering questions at the end of the webinar, so please feel free to type in your questions into the GoToWebinar control panel in the questions section. And now a little bit about binary defense and TrustedSec before we jump in. Binary Defense is a managed security services provider and software developer with proprietary cybersecurity solutions that include SOC as a service, managed detection and response, security information and event management, and counterintelligence. With our human-driven technology-assisted approach, Binary Defense is able to provide their clients with immediate protection and visibility, combating and stopping the next generation of attacks that their businesses face. Next is TrustedSec. TrustedSec is a full-service information security firm dedicated to helping partners to build their security programs, test them, and fix any issues that may arise. Their team of InfoSec experts were handpicked for their technical skill, ethical character, and dedication to helping organizations become more secure. TrustedSec consultants are backed by an industry-leading research team dedicated to exploring the best ways to serve customers while continually advancing their own expertise. Our speakers today are Justin Vaicaro and Randy Pargman. Justin is the Senior Incident Response Consultant for TrustedSec and has 12 years combined military experience serving in both the Marine Corps and Air Force. He has 20 years of experience within the information technology industry, with the last 10 plus years solely focused on security engineering. Randy Pargman is the Senior Director of Threat Hunting and Counterintelligence at Binary Defense. He joined in 2019 and had previously spent 15 years at the FBI as Senior Computer Scientist with the Cyber Task Force based in Seattle, Washington, as well as the Global Cyber Action Team. And with that, I will hand this presentation over to Justin.
All right. How's it going, everybody? Okay, so what we're going to do, we're going to jump right in. It's going to be basically a fire talk here. We got about 15 minutes to give you all the information around my presentation here. So what we're going to do is look at before you actually start a threat hunt, engagement. So these are going to be things to consider before actually jumping right into a threat hunt exercise. You're going to want to know what threats are specific to your organization. These threats can be specific to geolocation, specific business vertical, what have you, but these are threats that are very important to take into consideration. Knowing your current logging capabilities and what those are, meaning do you understand what's being forwarded, what type of visibility gaps do you have, the security solutions that you have deployed in their logging capabilities. Do you know what your critical assets are, where those critical network segments are, or where your critical data resides? Have you analyzed your environment? Most importantly here is, do you know what known good traffic patterns look like? Do you have a formal threat hunt process developed? Have you given any thought into what that looks like? Is your threat hunting integrated into your SOC or your incident response processes? This is where a lot of organizations have a slight disconnect between the three pieces, but it's very important to integrate the threat hunt process into each one of those existing processes that you have. And are your threat hunts aligned with the goals of your business? Have you spoken with the execs, other business teams, and what have you? And then, do you have specific metrics and measurements to help derive what an ROI looks like for your threat hunt exercises? So with that, we'll go ahead and jump right into a threat hunt engagement use case. But one of the things that we typically run into when jumping into a threat hunt engagement is clients really don't know where their key data resides, and most organizations don't understand or know or have the time to really understand what known good traffic looks like, meaning baselining their traffic. And then for the threat hunt engagement, the simple output from the client is just find bad. And so that leaves a very wide open net for us to embark on, and we will find bad. It's just the approach that we'll take to get there. So on that note, we'll jump into the actual use case that I'm going to talk about. And I wrote a blog post a few months ago, and it was specifically around an outbound RDP finding. And this is how it started off. Went ahead and put together a threat hunt hypothesis. So what I did was identified suspicious internal to external remote desktop traffic that may look suspicious. So that's the actual hypothesis that I went ahead and came up with. From the hypothesis, I went ahead and put together an assumption. So the assumption in this case is that most secure organizations won't allow internal to external RDP connections. Those type of connections should go across existing site-to-site VPN or a B2B type scenario here. So there should be no reason to go across the public internet utilizing that protocol. So the initial detection query that I started off with is, again, here we tend to use or try to leverage as much as possible the client infrastructure. So in this case, I use the client's SIM, and the initial query focused solely on RDP as a protocol. It excluded all internal subnets as a destination. I went ahead and filtered out all of the known client-owned external destination IPs, and that's very important in this case because the client was geographically dispersed across the entire globe, so that was very important to put in there. And then, so taking this approach after that initial query, a Hungarian IP address immediately stood out. And so from that initial finding right there, I'm going to kind of walk through, I believe it's 5 pivot steps that I use to get to an end result. So let's go ahead and dive into that. So on the first pivot, I went ahead and did a second query within the client SIM. This time I specifically filtered on the Hungarian IP address. And from that IP address, I was able to see firewall logs that were specific to this communication. And the important thing that was identified here is that that RDP connection was allowed. So it was, I verified that the outbound ACLs on the firewall were not filtering this type of connection. So it definitely added a little bit more layers of suspicion with this finding. So the next pivot that I did, I went into doing some light open source intelligence gathering surrounding the IP address itself, the Hungarian IP. My tool or place that I like to go immediately is just to look at Shodan. Shodan will give us some telltale signs of the ports that are open, history around it, and give us some other context surrounding the IP itself. So with that, I went ahead and also identified that it had some web-based ports, in this case 443, that was open. And once I find that, one area I like to dig into is the SSL certificates. There's a lot of valuable information that can be derived from that. So in this case, I went ahead and identified the certificate when it was established, and it was fairly new at this point. It fit basically right in the timing of this threat hunt engagement. So that was just something to take note of. And the other piece that I identified is that the certificate was issued by Let's Encrypt. So just other things to take note as I was working through this threat hunt itself. So the third pivot here, and this is based off of the web application, obviously, that we just noted in the last piece of information there. I like to use a passive kind of scan tool that's known as URL scan.io, and from there I went ahead and identified that there was a default web service that was configured. I'm sorry, that was exposed but not configured. You can see that from the screenshot. And so from that, I took that piece of information and I dug into it a little bit more. I just didn't stop there and say, okay, great. It looks like an admin admin step that was missed or just bypassed. So what I did was I dug into that. I identified that that actual device was a Synology NAS device, and it had the DiskStation Manager web services set up, but obviously not configured fully. I did one more validation check using curl, and as you can see, I just got the welcome message from that. So as we can see, it wasn't a direct, say, an operating system it was connecting to. It was actually connecting to a storage device. So that added additional layers of suspicion from this finding. And so the last pivot here, I then moved into the client's EDR tool. And from there, now I wanted to kind of break away from the network finding itself and look at more of the endpoints and see if I could identify outside of the logs from the SIM and see if I can derive a little bit more context surrounding the finding. And so from that, I went ahead and ran, a very simple query, just filtering on the Hungarian IP address. And from that, it identified a single host with 3 separate RDP connections to that Hungarian IP. So taking that information, I did some light frequency analysis with the firewall to see if anything stood out, whether session length or bytes transferred, bytes received, and so forth. Really wasn't too much data that came back, other than I found one interesting session that lasted for about an hour. So again, that added a little bit deeper context into what was taking place with the finding. And again, I was just putting all this information together. But unfortunately, from a consulting side of the house, when we're working through threat hunts, we run out of time. So what I did with this is I did a little bit more research around the Synology device to help me understand how it actually was handling RDP connections. And from that, through the simple research I did, it helped me understand that the RDP connections were actually being port forwarded on the NAS appliance to actually a back-end host. Due to timing, though, I was unable to identify what this host was, but that added a little bit more context as far as how, or actually what those RDP connections were doing on the destination side. So these are, unusual RDP connections that this finding kind of identified. And so what I did was at this point is I had to kick the finding over to the client. The client now had to take this information and simply either identify, was this going to be a legitimate incident to be called based on the information that I put together for them, or is it just simply a business process that needs to be hardened? Meaning, do they have to look at their firewall configuration, specifically on the looking at outbound direction? Do they need to put more enforcement in place and so forth? So as we can see, RDP connections can go unnoticed, and they can go unnoticed because of not properly having network access controls in place, simple egress geo-blocking not being enforced, and SOC network traffic baselining not understood. And this goes with the known good traffic. And so what we saw with this is that putting a hypothesis together is very important. That hypothesis will help you drive your threat hunt queries, and those threat hunt queries are going to be based off of what security appliances or tools that you have at your disposal. From the client side, again, we're looking at what the client has for us to use, or we would possibly look at leveraging some of our own tool sets to drop into the client environment and so forth. But the biggest thing that I like to call out is don't just take the finding face value of what you receive firsthand. That initial finding could then obviously trigger other additional low-level findings, which adds deeper context and possibly allows you to put in place a little bit more granular and specific guidance as far as what to do with that finding when you're handing it over to the client. All right, so now what I want to do is how do you take that the threat hunting, whether it's your program or process, to the next step or the next level here? And some things I like to recommend to the client post engagement is chaining your operational events and your alerts. And this is usually done at the SIM, or it's looking at what you have available at the time of you doing your threat hunts. Again, it's working with your executives, your business teams, your disaster recovery resources, again, to help drive your threat hunt, I would say exercises or even your long-term goals. And we could look at that, through tactical goals or, strategic-based goals. And then your focused threat hunt campaigns. Again, that goes back to understanding what are your threats, based on your business sector, your geographic location, and so forth. And then you're going to want to look at, integrating your threat reconnaissance into your security operations and also your threat hunt program activities. And threat reconnaissance can easily be, third-party threat intelligence and so forth. And then you want to look at building out your security operation team dashboards. Again, visualization is very important. And what I find is a lot of SOC teams, they actually don't even have any dashboards set up. Each one of them is sitting at their own console. They're looking at their own data, but there's no shared dashboard that the teams can look at. And then you want to look at steering your threat hunt strategy to focus on your critical assets instead of being more of a haphazard or generalized approach. This way you can get some really significant ROI by tuning down or basically being a little bit more granular and tactical in your actual threat hunts. And then you want to transition, obviously, your threat hunt exercises into more of a formal process. And then last, this is kind of important because a lot of people want to dive into threat hunting, but unfortunately, you're either going to run into staffing concerns or you just don't know how to get your program off the ground. So an easy way to slowly move into threat hunting would be to have a dual operational role, turn a SOC analyst into kind of like a hybrid individual, meaning they're going to be either your threat hunter or a good term that's, I guess, being used nowadays is your detection engineer. But you can put them as maybe a few hours a day to do threat hunting, or maybe a day or two during the week, or what have you. And however that plan works out, it definitely is valuable to actually put some significant planning before you actually embark on your threat hunting program itself. And so with that, that is all that I have.
Thank you very much, Justin. This is Randy Pargman from Binary Defense. I really appreciated the time that Justin put into that and that really clear explanation. It was a really great use case example that you gave as well. One of the things that Justin mentioned was operationalizing your threat hunts and turning them into detections. That's something that I'm going to speak on as well. I just wanted to make that point that it is really important to start with threat hunting, which is an open-ended question, something that you're curious about on your network, what is going on that might be unusual or weird, and then really digging into that, following it all the way to figure out if this represents a threat that you were not detecting before, or it's just something that might be a little unusual, or maybe even just an operational error that you need to correct. But once you get past that point of understanding what this query should look like, you really should be working that into a detection rule. Make it automatic. Give your SOC analysts the opportunity to detect when something like this comes up again. Something else I wanted to mention right at the start that you probably got from Justin's enthusiasm on this issue, but threat hunting is fun too. It is pretty exciting work, and it is challenging, puzzle solving, really a great challenge for technical people to dig into asking tough questions of your data and figuring out what is going on. Justin covered network-based threat hunting, which is a really important aspect of the overall approach. And I'm going to talk about host-based hunting. Not that one approach is better than the other or should be used to the exclusion of the other. Really, you should be going after both. But there are some things that make host-based hunting particularly important. One of those is the fact that some malware, some backdoor access actually uses network patterns that don't look unusual and that are fully encrypted and can't really be inspected. So let me give you a practical example of that. one of the pieces of malware that I came across during a threat hunt actually made use of Google services and a legitimate Google account to do its command and control. You can go back one slide, Justin. It used Google's hosts, so it was going out to legitimate Google domains and IP addresses. It was using proper TLS encryption, so the content of the traffic could not be inspected, and the Google host was just set up to act as a proxy to forward on to the attacker's infrastructure. So sometimes when you're looking at the network, no matter how hard you look, you're not even going to be able to see the threat there if the threat has been set up that way. But everything has to happen on endpoints. Most of those endpoints are workstations and servers. There's also some threat activity that can be happening on routers and switches too, so you need to look there as well. But there's a whole lot of great detail that happens on workstations and servers, and that's where you should spend a lot of time doing threat hunting activities. So what do you need to be getting from those workstations and servers in order to be able to set up an effective hunt? There's really two requirements. One is you need your event detail to be sufficiently detailed enough, your event data to be detailed enough so that you've got enough stuff to query against. And I'm going to get into the details of that in just a moment. You also need your search platform, whatever you're using to query across that data, to allow you to make expressive queries. In other words, whatever it is you as a threat hunter are thinking about what you want to look for, you need a way to be able to express that in the query language that your platform allows. Now, you could try to do threat hunting just grabbing a whole bunch of raw logs, loading them up in Windows Event Viewer, or if they're from a Unix or Linux host, you could try loading them up in VI and just searching and grepping and stuff. That is not an effective way to do threat hunting. I mean, unless you know exactly what you're looking for and you're searching for a particular pattern, you are not going to be able to see the unusual things because that just doesn't allow you to really get the big picture. So you need some kind of a platform that lets you query. There's lots of them available and they all have different capabilities. But you need to think about that when you're setting up. Do I have enough detail in my logs? And does my search platform allow me to be expressive in my queries? Go to the next slide, please. Thanks, Justin. So let me give you just a real high-level example of event detail for host-based events. A terrible example would be all you're collecting is log on, log off events, just authentication. That's it. So you basically, this user account logged on from this IP address at this date and time. Let me make a comparison to the physical world, an analogy. That would be like if the only security system you had for your very important warehouse that had very valuable goods is just a key card at the door and anybody could come in and out. There's no cameras, there's no guard, there's no anything else. And then somebody tells you, hey, I think my key card was stolen 2 weeks ago while I was on vacation and somebody might have been using it to go in and out of the building. Well, about the only thing you're going to be able to tell is what time did somebody come in and out. Like, you're not going to have any detail with that at all. You won't know what they did, you won't know what they stole, you won't have any idea the difference between the real person and who should be using that key card and the thief, right? So if you've got that level of detail in your logs, you really need to rethink your logging strategy and put some thought into how to do it better. So let's go into how would you do a little bit better. This is not a whole lot better, but every time a process starts, a program starts up, there should be a record of where did that program start, what parent process started it, and what were the command line arguments that were given to it. This, again, is not sufficient to help you with everything or help you find everything that you might want to look for, because people can enter into a scripting environment like PowerShell or Python, and they could type interactive commands and do a whole lot of things, and the only thing you'd see is PowerShell ran. But this does get you a long way down the road toward having better visibility into your environment. A lot of threats you can detect just by looking for strange things going on in the command line, things that don't really look quite right. I'll get into a practical example in just a moment. Best would be all the detail that you can get. So I didn't exhaustively list all the things that I would like to collect. These are just a few examples, but how about if you collected the Authenticode certificate information from every process that started instead of just the process name itself? What if you collected information about when one process injects code into another? That would be even better. How about network connections from processes? That's actually tying together this host-based and network-based threat hunting so you can connect those dots and not only know there was a suspicious connection out to this IP address, but this was the process that was responsible for that network connection. How about DLL loads? That's really important because some threats actually come through by DLL side loading or a legitimate, expected, normal process that you wouldn't think is a threat at all loads a DLL, but because of the search order that it looks for that DLL, the attacker has planted a malicious one with the same name and the same exports in another location. So basically you're looking for where did that process load that DLL from, and did it come from the wrong place? That can be a telltale sign that something is weird and you need to look at that DLL, figure out if it's malicious. Even better, what if you could get all of the file rights and the registry rights that a process makes? This is getting noisier and noisier, but now you have a lot more detail. What about files that have been deleted? The Sysmon version 11 introduced a really cool feature that actually lets you set up the ability to capture files if they are deleted and note whether they were deleted by writing over them with zeros or by just calling delete. And it actually saves a copy of it in a hard to get to location so that you might have some more forensic artifacts. So you can see the level of detail that you collect can go from terrible to best just by some configuration changes. Now, I do want to say it is not a great idea to just turn on all logging and collect everything. You're going to be quickly overwhelmed. There's just too much. So you do have to put some thought into what you're collecting and why. But I definitely appreciate environments that have more collection than not enough. Next slide, please. I want to talk a little bit about how threat intelligence can be practical. I really put threat intelligence into two major categories or buckets. One is the big picture, and that's what attack techniques have been used against other people. I'll give an example here. A lot of universities make use of the Stinger program, which is developed by Duke University and shared among lots of higher education. So if you're in the higher education space, definitely check that out. Basically what they do at a high level is they put out honeypots outside the network or at the network perimeter that are detecting when attackers are trying to break in and trying to brute force SSH passwords or do other things, anything that's detected as malicious, and then sharing information about that IP address with all the other universities so that if somebody attacks one, well, they can be blocked from that IP address from all those other universities too. If you're not in the university or higher education space, there's all kinds of threat information trust sharing groups. There's commercial sources of threat intelligence you can pay for. There's great open source things like the Alien Vault Open Threat Exchange, OTX, and many others. And those will give you information about specific attacks against other companies or other organizations, and you get useful information that way. You'll get, this IP address was used for command and control for this piece of malware or whatever. The problem with that, though, the oversight or the reason that doesn't cover everything is because attackers can actually change some of those things. Like they could come from a different IP address when they're attacking you. They might have spun up or paid for a leased server just to attack your organization, and it has not been used against anybody else. So in those cases, you're not going to get that kind of threat intelligence. You also need to understand what techniques are attackers attempting against your company or your organization. You really should look at email that came in that was blocked by your protection systems and see what was somebody trying to run. If an employee had clicked on that link or opened up that document and run the malware, what would have happened? You can get a lot more threat intelligence out of examining those things because an attacker actually targeted you, or you're part of a broad targeting set. But in any case, it did arrive at your doorstep. They were trying to get into your network. And if it had succeeded, then that malware would have called out to this IP address, or it would have dropped this host-based artifact or something like that. That can drive your threat hunting. Threat hunting is really applied threat intelligence. That's what it is, taking information, making it actually useful by searching in your network for these things. You also should think about deploying honeypots. Now, there's a big difference between honeypots that are high interaction, low interaction, whether they're outside your network or inside. I generally recommend inside your network, low interaction honeypots. Basically, you want to set it up so that if anyone interacts with that honeypot, it's pretty much 100% positive something bad is happening in your environment. That way you can set it up to actually, page you in the middle of the night and alarm you without you being overwhelmed. But that could be a whole nother webinar. We could talk about honeypots another time. Next slide, please. I also want to talk about this practicality of causing the attacker more trouble than you're expending to cause that pain. So the pyramid of pain is this really great visualization of this idea. And I want to make it clear, the pain we're talking about is the attacker's pain, not your pain. So unless you are the attacker, not the defender's pain. So the attacker has to go through work. They have to take some time and effort and spend a lot of time troubleshooting and developing and coming up with a way to attack you that's not going to set off your alarms. Now, if you've got an environment set up with no EDR, no antivirus, no firewall, no detections at all, well, you're basically making the pain point zero for the attacker. Anybody can attack you, and probably they are already. So most places have some kind of setup to detect attacks. And the attacker's job is not to say, look at an organization and say, oh gosh, they've got some antivirus, so I guess I'm not going to go there. Or they've got some endpoint detection, so I guess I'm not even going to try. No, an attacker looks at that as a challenge. They want to overcome your defenses. They want to bypass or evade your detections so that they can do what they want on your network, steal whatever they want, and not be detected. That's the point. Attackers are trying hard not to be detected. Your job as a defender is not to seal off the walls and make sure nobody can ever get in. That would be impossible, and that would also lock all of your real users out. Your job is to make it as hard as possible, very, very difficult for an attacker, and keep upping that level of difficulty. In other words, cause more pain for the attackers who are trying to get in. Hopefully that makes sense, because if you can cause the attackers so much pain that you are able to deploy in 1 hour of work, something that caused the attacker to have to go back to the drawing board and do 1 week of work to overcome, and then they come back and you detect them again, and now you can do another hour of work and make them do a week of work, well, that's a losing game for the attacker. They are going to move on to an easier target. But how do you actually accomplish that? The way that most people accomplish that is actually not very effective, because they're going after things, static indicators of compromise, like IP addresses and hash values of malware files that the attackers are using. That's where most of the threat intelligence and antivirus simple solutions live. And that is not effective because it's easy for the attacker to change. It's not painful for the attacker to change things like IP addresses. All it means is they have to pay another $5 or €3 or something to lease a new virtual private server somewhere that they can spend an hour setting it up. They've got a brand new IP address you've never seen before. Easy for the attacker to overcome. Hash values for files, that's even easier. All they have to do is take the same malware they've been using, add a couple of bytes to the end. Malware still works just fine, but it has an entirely new file hash. So they've overcome that. That's not where you should be focusing your efforts. Your threat hunting really should be aiming at the top of this pyramid of pain for the attackers. You should be going after detections that will be able to let you know if they're using any of their tactics, techniques, procedures, or their particular tools, or some network or host-based artifacts, like some actual content going across the network that you can say, hey, anytime I see this pattern, I need to alert on it, or anytime this type of pattern emerges on my endpoints, I need to detect it. So let's get into an actual example. Next slide, please. All right, so let me give you one example. There's so many that we could go over, and perhaps in the future we'll do a more deep dive on some of these and go over some recent techniques. But here is a piece of malware called EvilNum. The name actually is a result of the fact it was a name given by researchers because this particular malware identifies the IP address of its command and control server by taking a little snippet of text off of a cloud-hosted site, and then that's like an integer representation of a number, and then it divides that number by 666, and then interprets that as an IP address, and that's how it gets to its command and control. So this works in a lot of different ways to evade detections very specifically. One of the ways is that the attackers use these shortcut files, Windows shortcut files or .lnk files. They're not the only attacker that abuses link files. This is pretty common and definitely ongoing right now. So if you're not looking at those files already, you should. Most people just use those shortcuts as what they're meant to do, just a shortcut to a program that you put on your desktop or your start menu or something like that. But it turns out you can actually hide a ton of other information inside those shortcut files themselves. In fact, you can put an entire JavaScript program just hiding inside the link file, and then when the program runs, it will extract that out using built-in tools like Windows Find. We're going to go into that in just a second. This particular example uses all built-in Windows tools. So it uses 4files.exe, which is on all versions of Windows, and allows you to use like a wildcard pattern to match a bunch of files in a directory and iterate over each one of those doing the same thing. Then it uses find.exe. This is like grep on a Linux or Unix system. Find allows you to search for a pattern and then print out the lines that match. So it uses find to actually grab out all of the lines of JavaScript from the shortcut file and save them off to another file. And then it uses cscript.exe, which is a built-in Windows scripting host file that allows you to run things like JavaScript and VBScript. Next slide, Justin. Thank you. So this is an example run of an EvilNum shortcut file on the AnyRun platform. You could run it on an internal sandbox and get the same kind of result, or you could actually just statically analyze the shortcut file yourself and figure out all of this stuff. So basically, this process tree is showing you, do you see that there's command.exe, the parent process, that then runs all of these other executables, 4files.exe, another command.exe, find.exe, another command, and then cscript at the end, right? So there's this parent-child process pattern going on that we need to think about. There's also the command line arguments. This kind of cuts it off here. With a bigger slide or with more time, we could dive into what all those commands mean exactly. But there's a really long command line argument to command.exe. And if you're looking at that command line argument, there's actually enough information for you as a threat hunter to just look at that and say, oh my gosh, this is definitely evil. There is no way that a legitimate developer did something like this. This is all about obfuscation and evading detection. So looking at those things would be really powerful, but you might be tempted if you are operating on the lower end of the pyramid of pain to just look at something simple like the hash value, like that MD5. If all you do out of this exercise is you take that MD5 and you put it into your block list, you might feel good about that, but let me tell you what, you're not protecting yourself from anything because every single EvilNum sample has a different MD5. I mean, every one is slightly customized. It's easy for the attacker to change. It's really hard for you to try to get all of the hash values for all of the attacks that have even come in the past, let alone try to guess what they're going to be in the future. So that's pretty much useless. What might be more useful though is the host-based artifacts like these processes and the command lines that are running. So some questions to ask for your threat hunting approach. When you see something like this is really your input to the whole process that kicks off your question. how would I detect this if an attacker was doing this in my environment? So first, you should be able to query your environment to find out answers to these questions, like, do users or scripts in your organization normally even use find.exe? What about cscript? Now, my experience is that, yeah, both of those are pretty common. But what about all three, find, for files, and cscript? What if they're all run from the same host? What if they're all child processes of the same command.exe? Like, that's an interesting pattern here. And even if the attacker wants to change a whole bunch of things around, like let's say they use some folder other than temp, or let's say they use a name other than for.png.lnk, or they use a pattern to extract the JavaScript that's different than tru4, which is what they used here with find.exe. They could change all of those things really easily, right? But this whole pattern, like this approach of having a shortcut file call for files and find and cscript, that's kind of bedrock to this attacker's approach. They worked a long time and they worked hard to figure this out to evade your detection. So if you can do a search across your whole environment and you find that it pretty much never ever happens in normal operations that somebody runs all of these programs, or maybe you can even make it sharper and you can say it's pretty much never true that a regular user in my environment runs find.exe and cscript.exe at about the same time. Like, if you can do that detection, now you've cut off an entire tool. You cut off a way that this attacker is going about what they're doing. That doesn't mean the attacker can't get into your system. What it means is if the attacker wants to get into your system, they're going to first have to figure out how you're detecting them. And then they're going to have to go back to the drawing board and try something totally different. And that takes a lot of their time. However, creating this query probably only takes you an hour or so. So this is where the pyramid of pain comes in. You're making your job easy and the attacker's job really hard. Next slide, please. So here's another example. This is from iced ID, another threat that is very prolific right now. And you can see, if you study this command line that I've copied here, and I encourage you to actually look at the details because the details are important. It is using a environment variable. It's setting an environment variable u to this util.exe, and then it's copying C Windows System 32 certutil.exe to somewhere else. But you notice it's not actually using certutil.exe because this attacker is actually thinking about threat hunters, right? They are trying to evade your detection. They know you're going to look for the use of certutil.exe because you've read a lot of threat intelligence reports. You know that attackers abuse that all the time to download things. So they've disguised it by this clever little substitution. They're just using cert and then adding this environment variable that adds util.exe on the end. So, okay, clever little thing. But then they're copying that legitimate Windows program, certutil, to a new file and path. They're not changing it at all. It's still the same certutil, still signed by Microsoft, but they're now calling it curl.exe and they're putting it in program data, right? So now they're calling that because they know that you're probably looking for them using certutil. So they're not going to call certutil, they're going to call curl.exe. And they also know that you're looking for this pattern, URL cache /f, right? Because that is a common attacker technique. So they're using some command line obfuscation by putting the up caret arrow between the letters, which looks really weird. You wouldn't expect that to work, but Windows is fine with that. It just interprets it as /URL cache /f. And then it's downloading a file, a cab file, from this external attacker controlled server. I just made up the domain name here to not give a real attacker domain name in this example. They're dropping that into a file called drop.tmp. And now here's the weirdest thing that they're doing, and definitely the most evil of all. They're calling reg server 32 to run that drop.temp file. Reg server 32 normally would be used to run a DLL file, and it's being called from this with this .tmp file, which is actually a DLL. So all of this is to disguise the fact that it's downloading a malicious DLL and running it on your system. That's what all of this is for. And all of the obfuscation, all of the work that the attacker went into trying and failing and experimenting and going back to the drawing board and trying again was to make sure that you weren't going to detect them. I guarantee you somebody spent some hours, maybe a couple of days, figuring all of this stuff out. If you've never tried it, it's actually kind of fun to try some of these things yourself. Like, you know you're not going to download an evil DLL, but you could download a regular non-malicious DLL. Just see if you can get past your own defenses. That's a great exercise. So now, if you are just taking this example and you're saying, oh, evilserver.ioc.com, that's a network-based artifact, or that is a network IOC that I can put into my block list, you're missing the point. That's not going to help you a whole lot because the attacker can change that super easy. What you really want to do is bust up this whole technique altogether. So you want to be looking for some file like curl that is actually a Windows executable that's been copied to a new place and renamed. If you can search for something like that, you've cut off a whole really interesting technique. One of the things that I do typically on threat hunts is I broaden this out. I'm not looking for just curl.exe being actually a version of certutil.exe. I'm looking for broadly across the enterprise, are there any Microsoft signed legitimate executables that have been renamed and put somewhere else? And when I do that threat hunt, I don't always find evil. Sometimes I find sysadmins who renamed PowerShell to something that they like better than typing PowerShell. But that's fine. That's easy to figure out. It's easy to figure out that that's normal and then put that into the ignore list. But most of the time, when those results come back, this is actually an attacker trying to obfuscate what they're doing. You can also pick up on lots of other things here too, like regserver.32 being called with a command line argument that's something other than what's normal in your environment. You're going to have to experiment to see what that is, but I found, practically speaking, it's usually like DLL or OCX or, there's a couple of others too. But anyway, you can figure those out and then look for weird file extensions. You can also just look for long command lines with some of these characters that you think are kind of weird. You're going to come up with lots of normal ones too, but a pattern like this might stand out to you. Next slide, please. So instead of hunting for very specific artifacts, try to broaden your reach. Try to search for the most broad thing you can that doesn't result in a lot of false positives. In other words, that doesn't match a lot of normal activity on your environment. This is really specific to your environment, but does catch anything that is outside of that normal. So if you are able to really detect what is abnormal on your network or on your host, that's where you're going to have a lot of power to figure out some attacker technique that you've never seen before. I gave these examples before, so I'm not going to go over them again. Let's go to the next slide and just about ready to wrap up here. I've got a bunch of practical examples here, and we'll be happy to share these afterwards. You might want to take a screenshot of this so that you have it now. I'm not going to go over every one of these examples because we are running short on time. I want to make sure that we've got time for questions and some discussion. But I'll just call your attention to the one at the bottom because I think that's really interesting and really valuable too. I've seen a couple of pieces of malware very recently that had an executable file hidden in an alternate data stream. This was pretty sneaky and not a lot of people were looking there, but once you know that this is a pattern attackers use, and it's pretty much never a pattern that legitimate system administrators use, hiding an executable inside of an ADS, this is something you can actually look for. It's pretty easy to find just by looking for that command line pattern. So that is as much as I have time to cover. As you can probably tell, I love this subject. I love talking about threat hunting. I think it's super cool, and I'd love to continue this discussion. So we might put together some more webinars, or feel free to reach out to me TrustedSec has a really great Discord server, and we've got a threat hunting channel on there. So feel free to reach out on there. There's lots of great people, and I hang out there too. Let's wrap up. Go to the next slide, Justin. I do want to mention really quickly, if you're interested in working with binary defense on threat hunting, something that we do on a very regular basis is work with our clients on threat hunting week after week. We come alongside their security team and we work hand in hand with them. So if you want to learn more about that, just go to our website, binarydefense.com/threat hunting. And the next slide. Justin, you want to talk about TrustedSec?
Yeah, sorry about that. Yeah, as far as on the threat hunting side, we basically take, environments with no threat hunting programs at all. We offer, threat hunting training, and we take a very specialized threat hunting engagements from many different clients, whether they're smaller shops all the way to larger organizations. So in regards to specialization, we can pretty much handle any aspect that that clients will throw our way. But the heaviest focus being on there is helping clients develop threat hunting programs, because again, as Randy talked about too, threat hunting is more than just jumping in and haphazardly looking for things. It takes a very methodical approach, takes a very thought out process. So again, it's looking at the program as a whole and not necessarily just that threat hunting exercise.
All right, and we've got a few questions. I want to address a couple of these, and Justin, why don't we take turns? We can both address them. But the first one is regarding the threat hunting process. How long should it take to complete a threat hunting for a specific hypothesis, including everything, handing it over to the SOC, improving detections, etc.? So that's an interesting question. It's a really good one. It's difficult to answer because, of course, it depends, right, on how complicated it is. But I'd say in general, you're shooting for, if you have, let's say that you've already done all of the research that goes into it, that's because that's probably the biggest variable on time. You've already got like a really great threat intelligence report that goes through how this malware works, and you've studied it and you understand this really well. So you've got a good idea what you're looking for. I'd say if you have good data and if you've got a good platform that lets you ask really good queries, or formulate really good queries to ask questions of your data, you should be able to get through that in less than a day of figuring out what you should be looking for, and then kind of fine-tuning your queries, going through the results for a single hypothesis. And then something that's really important is once you've got the results of that, you understand, okay, this is what normal looks like, this is what abnormal looks like, this is something I think we could alarm on. You need to create a detection, but you also need to document that. It is really important to not just have something that's now going to be setting off alarms, and then when the person handling the alarm gets it, they have no idea what's going on, or why did this even generate an alarm. So an important part of the threat hunting process is going all the way to developing the detection and putting it into some kind of shared documentation repository. You should have some kind of background on why this threat, how this threat works, why this detection works, and then some suggested steps for following up. How would you investigate that? And Justin at TrustedSec uses a really great framework that maybe, I don't know if you'd like to talk about that a little bit, but I think that is really helpful to have a framework for documenting your results as well.
Yeah, sure. One of the frameworks that, as Randy was talking about, that I like to recommend, it's been a while, it's been around for a while. It's the ADS framework through Palantir, and it really drives home again what Randy was talking about on the documentation side, because working through threat hunts, it is super important to document. So that way you have something from a historical reference to go back to. It really helps drive home putting some kind of strategic vision into your threat hunting exercises. It allows you to develop a sound hypothesis, put together all of your critical assumptions, and then it really helps dive into understanding what logging do you have available, because what you want to do is, as you're running through the hypothesis, one thing I also like to throw out there for clients is to use your offensive frameworks that are out there from an automation perspective. There's one, for example, would be through like Red Canary and so forth, where you have these automated scripts that'll actually run through some of these scenarios for you. So it takes a lot of the burden out from a testing perspective, but it allows you on the back end to see, okay, what logging am I picking up? So that helps you understand from a detection perspective, okay, what can I see now? What are some of the not visualization, but what are some of the visibility gaps that I can see from this? And so you're able to tune that process, and then it helps with the reoccurring exercise as you move forward. But most importantly, again, it's getting everything documented. It's allowing you to go back in there from a historical perspective, because as you're working through your maturing your threat hunt program, you want to revisit the existing detections that you have in place, because TTPs change over time. And so you want to evolve your existing detections based on the changing of those TTPs.
Those are absolutely awesome points, Justin. Thank you for bringing those up. I also want to echo that. You cannot sit still on threat hunting. So as I mentioned, attackers are studying your defenses and they're trying to evade you. You can't expect that attackers are just going to keep coming at you with the same thing day after day. You need to stay on top of that all the time, as much as you can. The next question we've got is, how much data are we talking about in a typical organization to have these kind of search capabilities? So this is important. My team searches small and large, but just to give you an example, well over 100,000 endpoints, generating millions of event records constantly. You need to be able to search across tens of millions of events. And that means you can't just kind of roll your own simple solution. I mean, Excel is not going to cut it as a search solution. You really need to have some kind of a platform. And again, we're not going to get into the details of different products, but there's a lot of different platforms out there, and many of them do support a massive scale. So you really need to judge this for your own organization. You should start with collecting your logs. Make sure you've got centralized logging. Take a look at what you're collecting and what level of detail you have. A great way to approach this is do a really thorough red team engagement. Hire a great external cybersecurity firm to do a red team exercise. Let them do as much as they can. Hopefully they actually do get into your network and show you where all the weaknesses are, but then go back and figure out, where did I see these events in my logs and where did I miss them? So, you can judge that really quickly and then turn on more logging. Then you will be able to tell where you need more logging and what kind of event volume you're going to have. Justin, what do you have on that?
Yeah, no, I want to echo most of what you just said there. Centralized visibility is key. Most organizations, try their best to implement, say, a SIM or any type of centralized kind of platform, but it's getting those key pieces of data off box into a central repository, so it allows for more seamless and centralized kind of threat hunting. Because the last thing you want to do is start to utilize multiple tools, do pivoting all across your infrastructure just to come up with just small artifacts from your threat hunts. So centralized logging is key. You called out the visibility gaps within the logs. So those would be the two key things to really look at, and to kind of put a lot of planning in place before actually embarking on threat hunting.
Right, and I think that is it for time. We've still got so many great questions. I'm going to try to answer some of those in the chat in the next couple minutes, but we can also try to get back to people on some of these questions. So love the interactivity. Thank you for your kind attention, and definitely want to continue the conversation on Discord. I think would probably be the best. So check out TrustedSec's Discord server, in the threat hunting channel, or any of the other great channels. A great crowd hangs out there, Binary Defense and TrustedSec both.
Yep, thanks everybody.
Thank you all for attending. And again, there will be a recording coming to you in your email following the webinar within the next day or so. Have a great afternoon.